In this video, we are going to find the forces that are exerted on all the joints in a Vise-Grip when we lock the handles of the Vise-Grip by applying 65 pounds of force into the handle. And at this member of the Vise-Grip, we are having a force which I am calling it force in member AF. And what I did, I found this angle, we have the rise and the run of that member. So this angle we can find out it is the inverse tangent of the rise divided by the run. So it's the inverse tangent of 1.25 divided by 3.5 inches, which is going to give us 19.65 degrees. And we are dividing this force in two components, one in x direction and one in y direction. So the component of x direction will be force at member AF multiplied by the cosine of 1965, which the cosine of 1965 is 0.94, and the y component will be force in member AF multiplied by the sine of 1965, which the sine of 1965 is 0.34. So this force at point A and point F, we are going to have exact forces that are applied. And we have divided this tool in three parts. One is the upper jaw with the handle, and the lower jaw, and then the lower handle. And these are all the forces that are acting on that part. So again, in order for us to use engineering statics to find the forces, the summation of all the forces in x direction must be 0, in y direction must be 0, and the summation of the moments with respect to any point in our system must be equal to 0. So now these are the members with all the forces that are exerting on it. So let's start on this picture, and let us go ahead and take the summation of the moment with respect to point E. And this is our point E. So summation of the moment with respect to E must be equal to 0. So let's assume that the counterclockwise direction is positive. So the first force will be 65, which is going in clockwise direction. So we have minus 65 multiplied by the distance between this force and point E. And this is point E and that force. So it's 4 plus 1 1/4, so will be 5 1/4 multiplied by 5.25 inch. Then the next force that we're going to have is this force, which is going again on clockwise direction. So we have plus 0.94 force in member AF multiplied by the distance between that point and this point, between point F and point E, this distance. And that distance is equal to a 1/4 inch. So multiplied by 0.25 inch. And then the last force is this force, which is going in counterclockwise, so it's positive, so it's plus 0.34 force in member AF multiplied by the distance between this force between E and F multiplied by that distance, which is 1.25 multiplied by 1.25 equal to 0. So if we go ahead and simplify that, we are going to have 65 multiplied by 5.25, which is 341.25 plus, then we multiply 0.94 by 0.25, 0.94 multiplied by 0.25 is 0.235 force in member AF plus, sorry, this one is, this force is also negative. This is minus, so this is minus, plus 0.34 multiplied by 1.25, which is plus 0.425 force in member AF equal to 0. So if we add these two, we are going to have minus 0.235, we are going to have 341.25 equal to 0.19 force in member AF. So the force in member AF will be equal to 341.25 divided by 0.19. So 341.25 divided by 0.19, which is 1796.05. So the force in this member is 1796.05. So this force in y direction will be 1796.05 multiplied by 0.34. So this force is 610.66, and this force will be equal to 1796.05 multiplied by 0.94 will be 1688.29 pounds. So this is also the same force as that one, which is same force as this one, which is 1688.29, and this is also 610.66. Now, in this picture again, we can get the summation of all the forces in x direction equal to 0. So the only forces that we have in x direction are these. So force in EX minus that is equal to 0. So force in member EX will be also 1688.29 pounds. Now, if we take the summation of the forces in y direction must be equal to 0. So in y direction we have positive 65 minus 610.66 plus force in point E in y direction must be equal to 0. So the force at point E in y direction will be equal to, we subtract this, so it's going to be 610.66 minus 65. So it's going to be 545.66 pounds. So this force is 545.66, which is again that force, and this one is also 1688.29. Now let's go ahead to this picture. We have that force, we got these forces. We can take the moment with respect to point B. So the summation of the moment with respect to point B must be equal to 0. So this force, again, let's assume that this direction is positive. So for this force is going the positive direction, 65 multiplied by the distance between this force and point B. So point B is here, and so the distance between point B and that force is, we have 1 1/4 plus quarter is 1 1/2, 1 1/2 and 3 1/2 is 5 1/2. So 5 1/2 inches. Then the next force is this force, which is going the clockwise direction, so it's minus 610.66 pounds multiplied by the distance between this force and point B, between this distance from here to here, so which is quarter and 1/4, 1 1/2, 1 1/2 and 3 1/2, which is 5 multiplied by 5. Then the next force, this force is in the same line as point B, so the moment of this force with respect to point B will be 0. Then we have this force, which is going counterclockwise in positive direction, force at point C, multiplied by the distance between the C and point B, which is 1.75 multiplied by 1.75 inch equal to 0. So if we simplify that, we have 65 multiplied by 5 1/2 is going to be 357.5 minus 610.66 times 5 minus 3053.3 plus 1.75 FC equal to 0. So if we subtract these two, this minus 357.5 is equal to, so the force at point C will be equal to 2016,695.8 divided by 1.75. So if we divide that by 1.75, so the force at point C will be 1,540.46 pounds. So this force is 1,540.46. So this force also, these two forces will be the same on the jaws of these two forces, they will be the same. So this one will also be 1,540.46. Now, if on this picture we get the summation of forces in x direction equal to 0, the only forces we have at x direction are these two. So this force then have to be also equal to 1688.29. And if we take the summation of the forces in y direction equal to 0, in y direction we have negative 65, we have positive 610.66, we have negative force at point B in y direction, and we have positive 1540.46 must be equal to 0. So the force at point B in y direction will be equal to 1540.46 plus 610.66 minus 65 is going to be 2086.12 pounds. So this will be 2086.12. So this is also 2086.12, and this is also 1688.29. So now we have the forces in all the joints. So we are done. That's it. I hope you liked it. And I had one request that someone wants me to solve some examples of the some example of problems in exact differential equations. So we are going to have maybe a couple videos on that subject. See you later.